Hey everybody, it is May 4th, 2022. May the 4th be with you. Yeah, I'm a nerd like that. You're welcome. This is Computer Science 1 at College of the Sequoias, Spring 2022 semester. We are doing a review of the final exam. The final exam is due May 14th, which is not this Saturday, but next Saturday at midnight. You will have from today and a half hour through all that time, which is about 10 days, to do this. So you have time to do it at your leisure. There are 3 questions, just like we've been doing on all the other exams, with a multiple choice quiz section. These will all be they shouldn't be available right now, but they'll be available in a half hour. Hopefully you don't stop watching my video at that time. I got a list of review topics we can cover, so I'll just pull it up and post it in Canvas. Let's just do half. Not Canvas. I'll post it in Visual Studios. So you will be prompted. It says it at the bottom of every final exam question where you got to submit something. You need to put your name. You'll be asked to say like what final exam question number it is. I'll just call this final review. And I'll put today's date, May 4th. We need that there. You're going to be asked stuff about functions. Although I have something here listing pointers, you are not being tested on pointers, of course. But you will be tested on arrays. You'll be tested on vectors. You'll be tested on classes and structures and some stuff like that. So don't forget, you need to include the IO string just to do the typing. If you're doing something that has strings in it, you need to include string. I know Visual Studios provides it for you free, but it doesn't work like that on every IDE, so you need to include it. If you want to do some randomizing, unless you're David Ferris, who's a crackhead with the randomize, he likes to use a complex one. Just doing include seed time allows you to do the random number seed and doing rand parentheses and then the percentage sign. C math for any math calculations you'll use, not arithmetic, but like if you're going to use the power function or square root function or something like that. Include vector when you need it. You will be asked to do prototypes and implementations down below on every single lab. I have deliberately stated it in every single lab assignment because too often if I didn't say it, I'd get people that didn't do it and it's like, this is not what I wanted you to do. So it's stated. Prototypes with implementations. That works with methods for classes or structures as well. So we'll look at the functions in a second. When we get to them, let's just go through and take a look at what's going on. Of course, you've got your standard C out with your insertion operator. These are the insertion operators. We're inserting something into the IO string. And ENDL allows us to end the line. So does /n inside the quotation marks. When you use functions, you usually use the name of the function followed by parentheses and what kind of stuff goes in it. This POW function is from CMath, and x is the variable to be raised to a power. The 0.3333 is the power it's being raised to. A power of 1/3 is like taking the cube root. So it looks like we're taking the cube root here. We have a bunch of different data types. We have integers. We have strings. I'll let you decide which David that I'm talking about here. Sorry, Lewis. If your name was David, you'd be in the loop. Let's see. We got chars. We can do chars. We'll go char y equals. When we're doing char or characters, we do a single quote. Strings, we do the double quotes. Let's call it V, not W. There we go. Let's go with W. W sounds fun. We've got doubles, just like integers, but we can have decimal places. You can even do it with zeros after it, but why bother? Let's do something fun. 2.71. We use semicolons and lines. You can use float. I don't really use it because you don't really need it. If your number is going to be really, really long, we can call it a long double, which allows for a lot longer decimal places or a lot bigger numbers. And we also have the option of making something constant. If we don't want a value to change, we can say constant. Okay. So we've got our C out again. With insertion operations, we're inserting the power function into the string or the stream. It should say power function is the square root of x. The square root of, or not square root, cube root. Cube root of 5, I don't know, 1.7-ish something maybe? I don't know. I have no idea. I have no idea what this cube root of 5 is. We'll find out in a little bit. Can you guys tell me what that's doing?
What was the question? I was paying attention to something else.
Oh, what does int y parentheses 10 mean?
Where's your y? Are you setting y to 10?
Yes.
Initializing it?
This is the same thing as saying int y equals 10. You create the variable y and you're setting the value to 10. Same thing. I use z here, so maybe I'll change z up here to be zz. Ooh, zz top. We're going to call that variable zz top. I don't know why. Just sounds good right now. Okay, so that does that one. Z, if we don't declare what it is, it just stores gobbledygook in there. Pointers is when we use the asterisk, and pointers point to addresses. So this one is going to point to the memory location of where Z is stored. Okay. We did our COUTs. Again, the insertion operator. This, the double errors, is the extraction operator. We are extracting from the IO stream the data that follows. So Z. Whatever the user puts, we're going to store it in Z. So that gobbledygook that's stored here is going to be replaced with that value. See and ignore is a good way of clearing up any, like the enter key takes it out of the IO stream and stuff like that. We can print multiple things to screen using separate extraction or insertion operators showing different variables. Quotient marks allows us to concatenate or add stuff to it. So we're displaying the X value and then we're concatenating a comma with a space on either side to it, then doing Y and stuff like that. We have our pointer. It says that Z has address. Z pointer was the pointer for Z. And it will say the address. If we want to reverse and get the content stored at the address, we use the dereference operator, which is the asterisk beforehand. And so that should give us the value of Z. Z was whatever we type right here. When we have functions, we can pass things into them, but functions have to be set up where we tell it. Let's look at the one we're doing right now, the regular function. We have a prototype up top. The value in front of it is what it returns. So it does not return anything. And its input goes in parentheses. It takes in one argument that must be an integer. That's just the prototype. It doesn't say what it does. We can scroll down below to see what regular function does. Regular functions right here. It just does a cout. So the regular function is just a print function. And it's going to print out the argument. You will be prompted. Let me see, where does this start? That's where the main ends. So this is where the implementation start here. I do not want to see a cout in any function that isn't labeled with print, display, disp, or something that indicates a printing. We're going to teach you good habits. So,
for clarification,
this
okay,
doesn't say it here.
You just want an argument there, or just a comment, or what are?
It should return a value. Functions that don't print should return values.
No, what I'm saying is that you're. Let me reread. I don't want to see a cout function that isn't labeled. So you just want a comment that says print.
What I mean is, if you need to print something that is a result of this function, do it in the main.
Okay, so you want everything returned to the main, and then
return to the main and print there, okay. Which will be used in the main, and you can print the value in the main. Good question. Thank you for asking. That's a good clarification. It's good policy. We did a couple things the last 2 weeks with separating into header files and resource files. And people do not want random shit being printed out in their code if they don't think it's going to happen. And we do a lot of that header and resource file when we're sharing our code with others, working as a team. This is just good programming habits to get used to now. It only has a little bit more work, but it's good to know. Here, these don't say print, so maybe they should. So I will add print to these, and I will go change the thing up top to say print as well. They need to match. The names up here need to match the names down below. And I guess they need to match in the main. I think I got it all. All right, back to the top. So print regular function here, where we're taking the Z that we entered on line 34. We're going to pass it into the print function. And so Z is going to come in down here. It's going to go, where's my print regular function? It's right here. What do I do with argument? Argument is Z. It wants me to do a cout, or an output to the IO stream from the function. This is what the argument is. Then we have an example of passing by reference to a function. Again, you're not being tested on this. The pointer thing, not being tested on pointers, but you will do it a lot in CSCI 2. Almost a majority of your work in CSCI 2 has pointers, so you're introduced to it here. The Z pointer has the asterisk after the data type. It's not in the name now. The asterisk is not in the name. It's handy. You'll notice here, I called the pointer and I named what it was pointing to. This is not required, but it is useful. It's very useful if you've got the time and the naming to tell you what it's a pointer to. That's a pro tip for you so you can keep track of your stuff. So here we pass the pointer in. What it does is it's passing the address of where Z is stored into the function. And when we come down to the function that implements it right here, what we have to do is dereference here. Dereferencing the address will return the value. Again, not on your final, but good to know. While we're here, we'll look at the other ones. We see a couple more, a print array and print vector. The print array takes in a data type where the variable has this array notation to it. And you should also pass in the size. Okay? Arrays need to be, you need to say what the array size is before you use it. So it's easy to set up, and by using it here, we can do this. We'll talk about for loops in a little bit. This one prints it. Here, the vector one takes in the vector. Notice vectors use the arrow brackets rather than the square brackets. And the difference here is you tell it what type of the data type is stored in the vector inside the bracket. So that's a little difference between arrays and vectors. Notice their use inside the function is often the same or related. Since this argument, this array, and this vector only store integers, there's only one thing in it, we can just return argument of I. So that gets us to for loops. For loops is one of our grouping structure, or our looping structures. We've got the do while loop, we've got the while loop, and we've got the for loop. I hope I've got do while and while up above. For loop is you start at a number and you keep adding one to the number until you get to a cutoff number. So we are going to start with I equaling 0. We're going to add 1 to it each time. So 0, 1, 2, 3, 4. All the way up until we get to the size of the vector or the size of the array. Okay. Remember that if we have an argument that an array that is got 4 things in it, the cells are numbered 0, 1, 2, and 3. So the size is the original value minus 1. Which means you can do that for loop one of two ways. We can either do it as it is, where it says specifically less than, or we could say I is less than or equal to size minus 1. Either one of these will work. You can't mix the notations though. I less than size minus 1 is not going to go to the end of it. And I less than or equal to size doesn't work. So bad juju for I less than or equal to size. This tries to access outside the range. So if you can do it wrong, and I've seen students doing this wrong, and that's why I'm bringing it up. Here, where you can screw up is you actually say, let's see, I less than size minus 1 doesn't go to the end of the array. It misses the last cell. So keep that in mind, whichever one you use. You need to be consistent with it. The vector, we didn't need to pass in the size, the array we do.
I'm not following your comment there.
Okay, like if I had array 4 and I said I
Right.
less than size minus 1, 4 minus 1 would be 3. I less than 3 would be printing out 0, 1, and 2. So does that make sense?
Oh, yeah. Okay, I see what you're saying.
Size, I'll add a little note just so it's there. Size equals 4. I less than size minus 1 is I less than 3, which is only 0, 1, and 2. We don't get the third, or we don't get array 3. And that's just how indexing works because it starts at 0. I'm really not a big fan of that, but that's how programming is. Uh, for vectors, we don't need to pass the size because vectors have a nice little function where we do dot size and an empty bracket, and it will return the size of whatever's in there. Or return the size of the vector. Sorry. So vectors are much the same as an array, except you can add and delete to them at runtime using pushback and popback. There's other insertion and erasing operators. They're a little more advanced. I wouldn't use them until you're comfortable using how to get to those positions in the vector. And you're going to do that in CSCI too. You'll talk about how to go through a vector step by step where you're looking at, like, if the vector is 10 long and you want to look at the 7th one, how to get there and look at the 7th and delete the 7th or put something in between the 7th and 8th. You'll explore that in CSCI too. Here's you're just getting an introduction for it. The only other function we have here takes no input, but it does return a value. This is one of the few ones that having a print in it is fine. The run again one is like a self-contained package. You will use the response in the main, but the couts here are not related to any insertion. There's nothing being put into the function. So this is just to prompt you to get the feedback that gets returned. Don't do that for your regular functions, only like a run again function. Because everything like that, where you're prompting what it should be for, should be in the main. Come back up here, see where we're at. We looked at the print regular function z and pass by reference. Those should give us the same values. Let's run it, take a look, see. What did I screw up? Line 29 and 37. Oh, I already used a Y. There we go. That's because I added stuff. Oh shit, square root of 5 is 1.7-ish. Or cube root of 5. So we got our printout of oh shit. Non-loop code is right here. Then we've got, we didn't do anything with the string David Rocks. But we have pow function cube root of 5, x equals 5, and it prints it out. It says user prompt, type in an integer. I like the number 13. I was born on the 13th. I think it's a lucky number, not an unlucky number. So I'm going to go with that one. So what is that doing here? 5, 10, 13. Here we set y equal to 10. Damn it. We have x equals 5 there. We've got y equals 10 here. Z we prompted me for, and Z was 13. So what we have to see, this is this line right here is line 37. See out the user prompt, type an integer. I'm sorry, 37 X, Y, and Z with commas between them. Line 38 says Z has the address of Z pointer. Z pointer returns the address of Z. So where this 13 is stored at in my memory banks is located at the hexadecimal number right there. And if I just want to return what Z has, I can dereference it with the dereference symbol, which is an asterisk beforehand. So that gets me, line 39 is right here. Z has content 13. The next thing we did was print regular function Z. So we passed in the 13. 13 came down to the regular function and said, from the function, colon space arg. And that's where we got this line right here. The next one was the print regular function by reference. There we passed the address of Z to it. And when you pass an address, you need to dereference inside that function to get the value. So notice here we've got a dereference value here. We're telling it, okay, the address is Z is right here. I don't want you to print out what the address of Z is. I want you to tell me what's stored at Z. So that's what's going on there. That's this line. Let's come up and see what we're doing with the rest. So we got float user age equals 5.6 or 5.5. Double. That's just talking about the different integer types. We did that above. The other data type that's common is the bool, the Boolean, which has either true or false. False is 0, true is 1, or anything that isn't 0. So here, Sentinel is 1. That's the default one. But if you're asking a value to check to see if it's a Boolean, if it says like 2 or 3, it will return that it's true because it isn't 0. Which seems like this is backwards. To me, something should be true, and then anything else you say should be false. Right? Like if I were going to say the true color of my shirt is red, that should be the only answer that works. I shouldn't be able to say brown or green or blue or turquoise. The true one should be the fixed value and everything else should be false, but that's not how C++ works. We already covered char. So it says cout A has a value of int A. So what we're doing here is we're finding the integer value of A according to the ASCII table of lowercase a according to the ASCII table. Okay. And so Z has an integer value of 122. Let's see what else we got next. So string, when we do the string, like I mentioned above, you have to tell it use or include string because it's not a built-in data type. It's not in the standard library. Or standard template library. So we need to tell it to include the string library. Don't let Visual Studios do it for you. I will mark your ass down for it. If you're doing a project and it's just for yourself and you never intend on sharing with anyone else, knock yourself out. But if you want to be consistent where you don't learn bad habits, get used to it now. So here we've got on line 55, we're declaring string username, but we have not assigned a value to it. It is in C++. They don't have C or strings in regular C. A string in a regular C is an array of chars. But there's nothing called string in C. So That's what C++ offers. We use cout, type in your name. You do need to use the get line to get a string. If you just do cin extraction operator, cin blank blank username is not going to work. It is a no-go. It will work for any string with no spaces in it, but not for like a full name. So if I put David Jones, I need get line. It will only record David if I use cin. And it will actually store Jones to go into the next thing that it has a insertion value. So you do not want to use regular cin when you have a string. Okay? So I will go in there and do that. I will tell it my name. I'll lie. Professor Xavier. That sounds good. We'll go with that. Whoa, we got a bunch of shit going on. All right, let's come back up here and figure out what happened. Next thing it says is it tells me my name is, this is line 59. We do a cout and we're inserting what was gathered from the user or me. Then we're taking a look in arrays. Did I do an array up above? No, I didn't. Good. So we've got constant size. That's what you want to put to declare we can't use a regular int size equals 5 because arrays cannot change size at runtime. So there's two ways of doing this. This way works, doing double my array bracket 5, but you shouldn't. And the reason why is if you want to change size, you have to change it everywhere in the code if you do this. If you do line 63 where the size is here and it's referencing size 62, if I change 62, it changes it everywhere that size is referenced in the code. So you kind of want to do this. Okay? So we've got an array. It's got size 5. So remember, this is 4 cells. Or size, constant size equals 5. Is a box. Is got 4 cells. Or 5 cells. This is, I'm going to shorten, let's not call it my array for the paper. I'm going to call this A. We were saying this earlier. This is referenced by A0. This is referenced by A1, A2, A3, and A4 here. So this is size minus 1 is the final cell value or cell piece. So what are we doing here in our code? For integer I equals 0 to I less than 5, this means we're going to go from 0 to 1 to 2, 3, 4, and the next iteration would be 5. 5 is not less than 5, so we stop. So these are all of our i's. And what we're doing there is, I don't like this. I think int num should be above. And we'll just say num equals random there. That's the better way to do it. The reason why is you do not want to keep declaring an integer variable over and over and over. You don't need to. So line 68 assigns a random value to it. We didn't see the random number generator that I saw, so this must not be random. What does the array print out? Oh, it's doing number divide rand by rand max. Okay. Let me go back to the code. So we're coming up with a random number between 1 and the random maximum number. Then we're storing in the array at block I. 1.0 is an explicit way of making a variable into a double, because num was an integer here. So rand is an integer here. By doing 1.0 times it, we're explicitly making it a double. When we divide by rand max, what we end up with is a value between 0 and 1. So that's what we're doing. Each time, for each thing in the for loop, we are store that value, store the value between 0 and 1. In I. Then we're going to do a C out with it, and then we're going to show the fraction value. So we've got the decimal value of 41 divided by 32,767, which is apparently rand max, equals that. And so we did this 5 times. We found the value 5 different times. Notice using the for loop, we didn't have to name 5 different variables to get it. Some students are programming their stuff that way and not using for loops. And you're programming in a very poor style. You should be using looping structures to reduce the amount of code. You can easily get code that is thousands of lines long, and you do not want to make it any longer than you need to. Okay? And then, so they print out what's stored in the array here. Here, they're actually just referencing what was done in line 68, and they're referencing rand max, which is 32,767. Okay. Then we're doing it. We have an array right here of characters. An array of characters looks identical to a string, doesn't it? We've got quotation marks around a name or a string of characters. So this is the C string version of a string. It's a string version for programming language C. It's like retro code. But you have to use the array notation when you do it that way, and it's a char, not a string. You can print it out the same way, though. You do not need to print it out as an array, going through it one by one. We can, but doing a C out of the name just will print out everything in the element right here. So line 77 is printing out John. And then we're looping through this. 78 through 80 is doing I equals 0 to I less than 5. So why is it going to less than 5? Because John is only 4 characters. I equals 0 to I less than 5 is doing 0, 1, 2, 3, and 4. That's 5 characters. Does anyone remember what's happening there? It's been a while. This was like week 3. So when we have a character string, JOHN, to show that the string ends, they have the null terminator operator. So it's got a null termination. That's in the final block. So that's why it's one bigger than the array size when you're doing characters. That's the only one that has that. Okay. When we're doing like a string name, like username, where I put my name up above, David Jones. Why is it not doing? What is it doing here? Oh, it's counting something else. Okay, don't get ahead of myself. Notice it's going through it. This for loop is doing one character at a time. Element 0 is J. Element 1 is O. Element 4 equals blank because the null termination operator doesn't show up on the screen. It's a void. It means void. It's not even a space. I don't want to put space because we know space has an ASCII character value, an integer value for the space thing. So it's a lack of entry there. It's a void. So what's going on in the next one? The next one stores my name. Username stored my name. That's what we did up above. My name. I put in David Jones. So what it's going through is going to each element or cell of my name. So capital D is the first letter. And it takes it and it's casting it as its integer value. And so that's what it's printing out. So capital D is 80. Lowercase a is 114. That's not right. Did I not enter David?
I entered at the beginning of class.
Let me rerun it. Oh, I didn't put David. I put Professor Xavier. That's the problem. Let me go back and put David Jones. I'm like, what the hell am I doing? Why is it giving me something wrong? So D is 68 for capitals. Capital letters, A through Z is 65 to, I don't know, what is it, plus 26? 91? And lowercase a through Z is 97 up to 122. Those are the integer values for on the ASCII thing. You don't need to memorize that. You're more than welcome to look up those things when you need them on the test. So that's what we're doing here. 0 through 10 is 11 things. David is 5 letters long. Jones is 5 letters long. The space is the 11th value. So space is the 5. Space is 32. That's what's going on right there. And then we start looking at vectors. So we're going to do the vector portion. When we use vectors, we tell it it's a vector. We use the arrow brackets, and we tell it what type of value the vectors are going to store. And then we name the vector. As it is, this vector, my vector, stores nothing. And it has size 0 at this time. So let me get a little more size there. It has size 0 at this time. What we do when we want to add stuff to it, we use pushback, or rather name dot pushback, and then parentheses of what's to be stored, value of what is to be stored, whether it's a string, whether it's a Boolean, in parentheses. This adds it to the end of the vector. So here we do I equals 0 to I less than 12. Remember, it's going the cell, this is the size of the vector. So the vector should be, say 12, but the elements of it are 0 through 11. So elements 0 through 11 of size 12. And that's what we see when we do the size command. So this is a method. Size is a method for the vector class, which is requires when we do vectors, we have to include the vector library. So make sure you include the vector library. Conveniently, as many of you are going into Calc 3 next semester, and you've probably might have seen the notation before. That's how we write vectors in mathematics, is we use that bracket, that arrow bracket notation. So it matches up with the math definition, the way we do vectors. Pushback adds to it. So this is what it's doing is the vector starts with nothing. And then we've got 0 through 11 here. These are the elements. You did it. You ready? And what's being stored in it is I. So we're actually storing the value of the element. So this is array bracket 0, but it actually happens to have value of 0. Okay. And so that's what it's reporting here. Vector size, we were using the size method. When we do the print vector, we are sending it the vector. Notice we don't need the brackets here. We've already declared my vector is a vector, and the arrow brackets are up here. But the naming of the function requires it in there. You need to show it. You need to tell it not only that you're passing a vector, but what data type is stored in that vector. Okay? So that's what we're doing there, is we're seeing out the elements at I. Why is it doing something different? 0 equals 15, 7, 24. What did I tell it to do up here? Oh, I'm pushing back a random. My bad. So I'm pushing back a random.
I'm busy.
These are not correct. So those are random numbers. So those are random numbers. The first pushback makes it a one vector thing. So the first time. When you do your second pushback, it makes it too long. And so on and so forth. So you're growing the vector like you would a train by laying down more track. Okay? So that's what we're getting there. Then it says my vector.clear. My vector.clear, well, it says right there, it clears the vector. It empties it. So let's do a new print vector right now. Let's see what happens when we've cleared it. So I'll rerun this. Save. I've added a print vector after the clearing. And what does it show? So it doesn't show anything. So printing out the vector doesn't show anything. Maybe we could see out. Let's see how big my vector is now that we've cleared it. I'm going to comment out some of this. I don't know what I can comment out. I'll just run it. So clearing it, the size is back down to 0. Not only is it erasing the values, it's deleting the cells off of it, or it's deleting the elements from the vector. So it doesn't leave you a vector with a bunch of empty cells in it. Clear is actually taking the cells away, or the elements away. Then we've got when you don't know how many the user type is. So this is a loop, a do while loop. We're doing a do while loop here. We declare the variable integer or temp as a type integer. And so a do while loop always triggers once. And a do while loop will keep triggering always triggers once. At least once. Even if it doesn't meet the while condition right out the gate. It always triggers once. And only stops repeating when the while condition is met. Or when the while condition is not met. So what are we doing here? It asks us enter as many integers as we'd like. And -1 is the prompt to tell it to stop. So it keeps asking if we want to enter it. We enter a value. It checks to see if that value. So we've got a comparison operator. This is checking to see, does temp not equal 1? And if is one of our control structures. Do while is one of our looping structures, as is for. Hiccups. So let's go through it, and I don't know, let's enter 0, 1, 2, 3, 4. That seems like a good stopping point. And then I'll say -1 to quit. So it does not store the -1 because of this control structure. The if says, if this condition is met, do what follows. If the line that follows an if statement is more than one line, you need to use curly braces. To be honest, it's a good idea to always use curly braces. That way you never mess up. So those two do the same thing. If you don't have the curly braces, but you have got a bunch of lines of code after it, it's only going to do the top one. And then it asked me, would I like to run again? This was the printing. Do we want to, do while. So it says looped code goes here. That's what we're doing again. So if I say yes, it should just do the looped code goes here part. That's the only part that's repeating. But if I enter a Q, it stops. So run again is coming down and asking why, if user response equals the lowercase y or the capital Y, set it as true. Anything else is flagged as false. So we've got another comparison operator. The equal signs. Double equal means check, compare. Single equal, like I equals 0, is assignment. We're assigning I the value 0. Here we're checking to see if user response has the value y. That's the difference. Remember that the double vertical pipe is the equivalent of or. And double and is obviously and. Okay. Let's see. Are we missing any structures? I think we are. So what else have we missed in this code? We've got the while structure, do while structure here. That's one of our looping structures. Let me comment all this stuff out.
Can I take a look at your run again real quick?
Yeah.
Okay.
I actually think this is stored in the announcements and stuff like that too. If you want to see it there. I know I got it in some code somewhere. We generated this in like chapter 3 or 4 whenever we started doing these control structures with if. All right. I'm going to comment that back out. I do want to comment it out for now.
Yeah, just mine is using a switch.
Right.
Basically the same thing though.
Switch was one of the topics I was about to discuss. So our looping structures. We have for, do while, and while. So while loops don't always run. The do loop always ran. So let's say int x equals 1. And I say while x does not equal 1. See out the value of x. So I'm just demonstrating real quick the difference between these two. I'll set it up twice. We'll do one where it says not equal 1 and one where it says equals 2. And I'm going to, that's going to create an infinite loop. Maybe I better show that. While loops can easily generate infinite loops. Do while loops, for loops also can all have this infinite loop. Actually, okay, grab it and stop. Nope. See, it keeps going, keeps adding 2, and you can see the cursor going down. There's no way to interrupt it. So, you want to have something in a do while loop or a for loop, whatever it is that ends the condition. In the for loop, it's that I++. Or if you're decrementing, I minus minus. That way, eventually, you get the index higher than the value. In the do while loop or the while loop, you have to have something inside it that changes the test condition. So I'm just going to say x equals 3 right here. So it only runs once. What should happen is it should say x equals 2. It should get to this, test it, go, nope, 2 does not equal 1. It's going to skip this value. Actually, maybe I better put some text here. Is not seeing it. It's not going to do it if I have the same CI in both spots. Now here, when we get to this one, x does equal 2, so it's going to do everything in the brackets, including print x to, or send x to the IO string, and then it's going to change the value of x. What the fuck? Oh, maybe I gotta do while x equals 1. That's, yeah, shit. I had the looping thing right there going on forever too. My bad. So the x equals 1 does not print because x does not, in fact, equal 1. That's the comparison. Assignment operator, comparison operator. Gets to the x equals 2. It runs once. After it assigns x equals 3, it no longer meets the test condition and it breaks out of the loop. So I will comment those out. And then we will get to our control structures. We've already seen one, the if statement, the else statement, and the switch. Else has to be paired with an if. So I can do if x equals 2. I can tell it what condition I want to run. And I can do these for a bunch of cases. This scheme is going to go through the way I have it set up and check x each time, no matter if it's already done it once or not. So this sequence of ifs checks all of them. And if you've done it a certain way, more than one might trigger, to be honest. But if we don't want to do that, if we only want to check for a single condition, we can use else with the if. So I'm going to come down here and I'm going to copy this and say else if. And this really should be in its own bracket. And this is an else if also. Why is it not liking that? Is it because of these brackets? It is. It does not like the brackets. My bad. Some languages want the brackets. Look at me done messing up. So if I do else if like that, you can do it this way. This is going to go through and check the conditions until it meets the condition, and then it stops. So we have x equals 2 here. It's going to go through and say, does x equal 1? No. Okay, it didn't equal 1. Does x equal 2? Yes. X equal 2, it's going to run this line, and it will never check these because the condition for the if-else statement has been found. This can get tedious if you're doing a lot of numbers because you get a lot of parentheses things going on here, which leads us to our final control group, which is switch. What's the notation here? Let's see, X. And we say case number. We say what the case is. And we'll have case 2. And I'll make it case 3. And I don't think that's a colon there. I think it's a bracket. That may be what's wrong. Yep, that's exactly what's wrong. So it's going to go through in sequential order and check to see what's there. If x equals 1, it will do everything from here on. It will do everything until it finds a break statement. even if it's in later cases. So I'll just say cout switch case, so we know what it's talking about, switch. And I won't use a break. And we'll take a look at what happens with and without a break. So I'm going to cout an extra couple lines here to get some space in there. So it got to the switch structure. We know x equals 2. Case 1 does not trigger because x does not equal 1. X equals 2, so it triggered everything after it. Okay, and it will go until it hits a break. So I could add some more cases. Let's just copy and paste it. But to show the break condition, what happens, I will put break after case 3. At the end of case 3, we break. And so now when we run it, it should go through. It says x equals 1. No. X equals 2. All right, do everything until we see a break. It should print out switch case equals 2. Switch case equals 3. It breaks, so it doesn't do switch case equals 4. And there we go. So those are our control structures. If, else if, or if, else, and switch. Else if is a conglomerate of two of them to make, it's the equivalent of doing a switch scenario, to be honest. But the switch has less writing. So that's those things. Now let's load the other code and take a look at classes. So I'm going to comment all this stuff out. And let's see, go to our lecture code. You know what? I'm going to put it before it. That way I'm not scrolling very far. There we go. So let's come up here and look what's happening. We've got our IO stream. We've got CMath, so we're doing some CMath in here. We are going to manipulate the IO stream. This is what we include, the library to include to set precision. We have a global constant declared before the main, which means this function or this constant right here, pi will be accessible in all of the stuff that follows, whether or not it's in the main. So like this complex class right here will include it. It has, not included, but has access to it. Okay. So we are doing a class structure here. Class structure is called complex. Complex is based off the complex number system, real plus in the imaginary component. And the difference between class and structure, maybe I'll put this in here. Classes default to private. Struct defaults to public. And I'm not going to say classes, I'll say class because that's the actual command name or the object type. So class here is an object type. It's the type class. We are declaring the object to be called complex. And it's good practice, although not necessary, to list what is private and what is public. You do not need to list for class the private, but it's good practice. It's very explicit with what you want. The same thing can be said for structure, but you don't have to list public. Both have their pros and cons. Class in general is frequently better for teamwork projects because you don't want people accidentally changing values in your shit. Let's be honest, a lot of us like to use X, Y, and Z as variable names. And if I had X or Y or Z in here and someone went to use, and it was in a public area, he could accidentally change my value of X depending on what he puts in his code. So we're going to make our variables private. That's the point of the class. So you keep your privates variable or your variables private. That sounds bad. But we need to give them access to them so they can change them. But they have to make sure they have to know they're changing them. So we come up with what's called accessor methods. We have set methods and get methods. Set methods always have a void return type. Void, void. And they have an actual value that is passed to the method. Methods are just like functions, but for classes and structures. So set real takes in a double, and it's going to assign it to the real portion. Set image or takes in an imaginary number, and it can be a double and sets it as a double. The get ones don't have any input. They don't take anything passed to them because they don't. They're just fetching values that are stored in the class. Okay. Then we have like utility methods down here. I'll cover constructors in a second. These are like utility methods, what we use them for. We have a print one. Notice it says void. It doesn't take anything in. It doesn't spit anything out. So all the printing is in this function for this method. It's also got methods to determine the magnitude of a vector, the angle in degrees of a vector, and the angle in radians of a vector. All stuff that we will be doing in Calc 3 if you're taking that next semester. Or in 2 semesters, or if you're already taking it. If you've already taken Calc 3, this is familiar to you. When we have methods like these, including the constructor, which I'll get back to, when we put them down below, we have to use a scope resolution operator. So let me go. Let's see. Implementations are here. Oh, that's not what I want. Undo that so it stands out. So we have to take the name of whatever the class is, in this case, complex, and we have to say this is where these methods are stored. This method, which is the constructor, let's do the other methods. The set methods, set real, set image, the get methods, the utility methods are all part of the complex class. They are in the scope of the complex class or the complex object. Each object stores its own set of information. So if you plan on using 3 complex classes, you do not need 3 variables in your class. You just need to make 3 objects of them when you create them. Okay? And it will automatically generate variables for each of them. But here we got to do the scoping, and that's what this is. The name followed by 2 colons. The set methods, you take in the method, you set it to the value of the variable. We had variables A and B, so that's where they're stored here. When we do the get methods, we are returning the parameters we have, or the variables we have, and we need to return a type that A and B are. A and B were stored as doubles, so we need to return this as a double. We'll look at the other ones in a second. Let's look at this one right here. When you've got the name matching the method, these are your constructor methods. As long as you don't have a void one, we can do what is up here. This only works if we don't have a void input constructor, which would be complex void. As soon as we do that, it kind of screws us up. We don't want to have both. Well, we do, but the part that, I'm sorry, when I say this only works, setting default values in the prototype only works if we don't have a void input constructor. So I don't want to have the void input constructor. What I'm going to do is have this. If you want to see a list of multiple ways of setting up constructors, watch the last video that was made. No one came. I was so lonely. Not even Lewis. I was alone. But I was going through doing a cryptology code breaking adventure. So that was fun. But if you want to see how a bunch of different constructors work there, that's a good spot to look at it. It's recent. Here, what we're doing is we're saying we're going to make a complex constructor that when we do parentheses and send in two numbers, we don't need to access them individually to set them. This effectively does all these set methods for us. And if it's set up well, the constructor actually uses the set methods down below. So we'll come down here and it does. It says set real arg1, set image arg2. So that's the preferred way of doing it. Another way of doing it is A equals arg1, B equals arg2, but it's not ideal. And the reason why is if you want to do any data validation, the data validation is easier to do in the set real part or the set parts, where we can say if A is, like if we only wanted positive values for the real number, we could just do a data validation check here. If A is greater than 0, A equals real part. Else, and then prompt them for a new part. Okay, so that's the constructor. We've got some magnitude, angle, and degrees, angle and radians. Let's walk through the rest of the code. We'll hit those when we get to it. All right, so some of you are using precision. Some of you are using fixed set precision. So there is a difference between these two. What was it? Someone just did it. They used. Maybe I'll put the fixed thing first. This is saying we can have as many numbers as we like, as long as they are before the decimal place. Then only one digit after. So 1, 2, 3, 4, 4, 4, 4, 4, 4, 3, 2, 1, dot 7 works. 1, 2, 3, 4, dot 7, 8, 9 does not report the 8 or 9. So that's what's happening. It's restricting what's sent. The set precision is in the IO MNIP class. I gotta look up the name for the other precision. I honestly don't like it, but there is another precision type that does sig figs. significant digits, significant figures. So it's kind of good in the sciences, but I don't like doing it automatically. I'd rather have it be part of what's calculated. The other one, like if you say 3, it's going to report 3 numbers, the first 3 numbers wherever they're at. It's not going to like anything else. It's not going to like numbers that are in the millions. It will do like 23.1, 2.31, stuff like that. I recommend doing fixed set precision like that. If you do 2 in here, you do stuff like money, which is a common one. So there are a couple ways to set up complex. The first way is when we call on it, this line, lines 40 through 42, are saying we want to make an object that is of the complex class. The first one, my complex, I am using the constructor to set the real, sets real to 3, and imaginary to 4. Same thing for y, it sets 2 and negative 4. Complex z does not have any constructor. So this will take the defaults, if they are set, from the other constructor. From the constructor. What is it getting? Up here, we set the defaults at 0 and 0. So z is actually making a complex object with 0, 0. Now, we have the option, and we can do it for any of them, not just the ones that have default constructors. We can always change the value. We don't have to do a cin to do it. We could just automatically change the value of the real. Right now it's at 0. I could say z set real. I want to set it equal to, these were doubles, so I'm going to say 15.0. And I can access those accessor methods using the dot operator with the name of the method. And I'll set this to negative 2.31. The other option is doing it with the cin like we have here, where you take the cin and you do it like this. There is some fancier ways of doing it. David and I were working on it, Ferris and I, he found it the other day. There's another way of doing it. It's a little more complicated. You have to remember the writing structure of how to do it. This approach always works. And I recommend learning it because you're going to use this a lot when you get to CSCI 2. You're going to be using the dot operator with accessing methods to iterate through steps or the elements of a vector. So this does the same thing as what we're doing here, but it takes input value from the user.
What were you trying to find there?
Where we had we did like cin, comma, temp, and the methods were set up slightly different.
Oh yeah.
You remember what I'm talking about?
Pull it up.
It's a little more complicated.
Yeah, I'd have to pull it up.
Right.
But yeah.
It's not easy to remember. This one is kind of easy to remember. It's the name of the method after the dot. And that's consistent across the board. That's the default way of setting up a method. cin always works the same as it always does. So this takes 2 lines to do what the other method does in 1. But the other one's tricky, requires setting it up right, and is not intuitive to other users. So like if you're sharing your code with other people on your team, it's a little more complicated. This is the obvious route of using a method like this. So at this point, we have 3 objects of the complex class. Each one has created its own A and B. There's a myComplex.A, myComplex.B, there's a y.A and a y.B, and there's a z.A and a z.B. It makes copies of this for each object. The reason why I'm pointing it out is some people were doing A1, A2, A3, B1, B2, B3, and making a bunch of different variables up there and trying to set only the portions that applied to the object they were looking at in it. You don't want to do that. You don't need all that extra stuff. You're basically storing a lot of extra blank spaces in there you don't need. So this does all of that. Then we created a vector that takes in the complex data type, and we're calling it myComplexNumbers. So we can do our pushback stuff with that. So myComplexNumbers, we're going to push back the first one we did, 3, 4, which is going to make it first. The second one, pushback, adds it to the end. Y will be added to the second spot. And then Z, which will be initially 0, 0. Then it's 15.0, negative 2.31. And then finally it's changed by the user. That will be our third component. What do you like as a better variable name here? MyVec or myComplexNumbers? There's pros and cons to each. You know what? If I'm doing something and I'm not sharing my code with anyone, I like MyVec. MyVec, and I'll put it here. If I'm not sharing code, MyVec reminds me it's a vector without being a long name. If you're using Visual Studio 2022 or an IDE that does the autofill, name length doesn't really matter. So if name length doesn't matter, or you're sharing code, use a look at, did you see how the way I spelled use? I spelled it like that. Fail. Use a vector or use a name that makes it clear what's in it. myComplexNumbers lets me know that there is more than one complex number in this thing. And I know that's what it's storing. Even later on, I don't have to come up here and look at vectors. I can see that it's a vector. It's storing, the name tells me it's storing complex numbers. So I know right away looking at it what goes in it. So then we got the C out. It does a C out of the size. My complex numbers.size. So this has 3 in it. My complex, Y, and Z. And then what we're going to go do through is use the print function, the print method. We're going to do a for loop. And the way we access for loops or access elements of an object, a class object, is using the name of the vector or array. Then we use the bracket notation to say element I, assuming you use I equals up here. Then we use the name of the method right here. And if it requires anything inserted, you put it in the parentheses. Magnitude and angle in degrees did not. So let's just take a look and run it and see what happens. So I don't know, 1 and 2. So what's it doing? The 3 is a C out of the size. This 3 right here is the C out of the size. Then it's going through the for loop and it's using, it does the print command. So it's printing. The first one was 3, 4. So it tells me the real is 3 plus 4 imaginary. Magnitude is 5. This magnitude is very much like the Pythagorean formula. Uh, so 3 squared plus 4 squared equals 5 squared. So the magnitude is telling me the length of the vector. That's what magnitude means. Then the angle is telling me the degrees off of the horizontal axis, the flat axis. You'll study that in Calculus 3 and trigonometry as well. Maybe pre-calc if you take pre-calc here. Most people go with trigonometry for incoming students. And it goes through and does each one. So it does all of the 3, 4, that is my complex. It does it for each of them first. So it gives the printout, it gives the magnitude, it gives the angle. The angle is related to the arctangent, which you will see when you're doing polar coordinates, like if you're in Calculus 2. Calculus 2, this is the r, not r, this is the theta in polar coordinates when you're doing converting. It's at the end of Calc 2. And it goes through all of the 3, 4, and then it gets to the 2, -4. It goes through all of those. And then it gets to the ones that I said, 1, 2. System, this cut line right here is a great way of putting in a pause that is useful in finding errors in your code. Like if you're not sure where something's glitching, put this at multiple points and just count how many times you have to press any key to continue to find out where your thing is. This doesn't do anything, it just ends it. One more thing. I'll do the same thing, but I'm going to do some pop backs here. So I want to do all this again, but between them, I want to pop. I'm going to do pop. I don't need to tell it what. This takes the last object off the end of the list. And so if I want to do it more than once, like if I do it twice, I can then see what the size is again and print out what remains. Let's throw an end line here. So pop back removes the last 2. So it should be removing Z, and then it should remove Y. It's working backwards. Uh, 6, 8. Then we work backwards. Size is 1, and it's only doing 1. So that's the ways you take things out of an array or out of a vector. We can't do that in arrays. There's no removing shit from an array. The only thing you can do with arrays is if you want to remove them, you got to make a new array that's just shorter. So that's the useful thing about vectors. That kind of hits all the major topics that we have. Don't forget to do prototype and implementations for functions and methods. Only do couts in methods or functions if it's a print function. And you're prompted for all the stuff like that in the problems. So if I come over here, it should be available now. Actually, let me click back in the back. You now should be able to access the test because it's after 4:45. I obviously wouldn't do this until you've completed all the homework. I'm going to grade Chapter 10's labs tomorrow morning. I hope I get them done all tomorrow morning. If not, I'll try to finish them tomorrow evening. That way, anything you need to fix for your 11, if you want to fix stuff for your 11 lab that uses your 10 lab, 10B, your triangle lab, you'll be able to fix it. But if you're all done and you want to knock the final out before the weekend, you can. It's ready. There's 3 projects. And there's...
Is the 10 triangle lab built off of the 9 triangle lab?
Did we do a triangle lab in 9?
Yep.
Yes.
Well,
the
we were supposed to have.
Yes, the 9 was that we did a triangle structure. 10 was we turned the structure into a class. And 11 was using... This one is doing the header and resource files.
Okay.
Okay? All excellent questions.
Question regarding module 11. I've noticed that it's under an unpublished module when I try to access the lab to try and do it.
Son of a bitch. All right. Now it should be back. Turn on.
All right.
Thank you. I am really glad you brought that to my attention. Has it been off the whole time, or?
It's been off the whole time. I was
Holy
wondering if
crap.
that was intentional or not.
That was
So
not bad. In fact,
okay, so 11C by May.
I don't know that you'll need it. It's kind of a short lab set. Go ahead and ask your question, Tyson.
Yeah, no, I was just wondering if that was that. And then we do quiz 11 May 6th and 11C, and then May 10th for A and B of the lab.
Oh, quiz. Oh, I need to change the quiz date on that. Let's just change that right now. No, this was not due May 6th. This was me using old Canvas setup and missing one. Other stuff changed, but I forgot to change that. That's a great question. I'll point out to you guys while we're here, just to show you the name of the first, or look at the first final project. So you're going to set up flipping a coin 500 times, tracking heads and tails using a Boolean function. It says here, be sure to separate all functions and methods if you choose to use a class or structure. And I know in one of the other ones, I have it specifically state that printouts need to be in cout, or couts are in printouts, but not in other ones. So maybe I need to add it to these two in case you guys use it. I'm trying to get you guys doing good programming practices. It's probably the final one, which had strings in it. Anyone that's played D&D will appreciate final app number 2. This one has it. I'll make a note in them about the display method as well. It doesn't have to say display, but it has to indicate something that it's printing it to screen. Just get you guys in the habit now. Thank you for bringing all that to my attention.
No problem.
Anything else? Anybody? That sounded a little harsh. Anything else, anybody?
I don't think so.
Nope.
I don't know if you guys are doing anything this summer. Let's see who's still here. Weaver's still here. Weaver and I are going to explore Unity. Unity is very similar to C++. It's for game design. We're just going to do a little personal research project. If anyone wants on board, wants to participate in doing their own research project, we can meet up on Zoom like once a week or something like that to talk about what we've done and stuff like that. If you want to do it, you're not busy in the summer, and you're interested in doing gaming programming, it's something that you can look into. That's a project we're doing this summer. It's not worth anything in terms of like credit, but it's going to make a hell of a reference letter if you want a reference letter from me later on. Not only will I be able to say that you were in my class and how well you did and how you participated, but that you have done a personal research project with me and explored stuff beyond the scope of what was required for your bachelor's degree. Plus, you'll get to learn about gaming coding, which isn't.
I'd like to be included in that.
You want in? All right. So I will make sure I email both Davids. I don't know if Tyson, if you're in or not. I'll check with Lewis. He does a lot of stuff too. He might like to do it. But I'll make an announcement about it.
I can't guarantee I'll be available, but yeah, I wouldn't mind getting some updates, and I might try and join in every now and again.
All right, I will make a Discord group called Dave's Unity Group or something like that. Hefe's Unity Group, and if you are interested in being in it, email me or join it. It'll be in my Discord channel, so check it there. And I assume everybody has joined the Discord channel. It's in the it's in that syllabus stuff, how to get to it. I will, whatever we talk about, I can record and I can upload the videos to YouTube and share them in the Discord channel as well. So if you miss it and want to stay up to it, we're going to do that. I know finals, when do finals end?
18th.
The finals end on the 18th? Awesome. Okay, so finals end on the 18th.
18th is the last day of the semester, I believe. So 19th
is probably graduation day then. They very much like to do it right away, like give no time for grading. You know what? I kind of want to go look. So COS. We're going to look at academic programs and classes. Let's see. Dates and deadlines. Has a lot of shit. We're in the, not fall, oh, it's got the new year. I don't want the new year. I check the old year. Rude. Oh, refer for other academic calendar. Okay. Just read the screen, David. Don't be a jackass. Just read the screen. This is not a good setup. They need to change this shit. This is bad. Oh. COS 2022 commencement, May 19th. They very much like to do this. I don't know why. I don't know why they make graduation the day after finals are done. It's unrealistic for classes that have a final on the 18th for a teacher to get grades in by graduation. But that's how they do it. I think it's because they use the same place as the high schools. It's one of the high school fields. And they don't want to conflict with the high school graduation. So, classes end the 18th. I'm sure everyone's going to want a break or two to unwind. But maybe I'll start doing something at the beginning of June. I'll send out stuff to anybody that's in. I'll send out stuff to the Discord channel on stuff on ways you can get set up for Unity, any videos that are good to watch before we get started, and we'll talk about it all at the first meeting, and we'll even talk about when we want to meet there. So we'll collect ideas for a meeting time or when to meet, and go from there. All right. All right. Sound good, everybody?
Yep. Yeah, that sounds great.
Awesome.
Have a good one.
You too.
All right.
All right. See you.
See ya.